Hello, I'm Dulce Amnesia Marasantitolobi with a SID number of 1021 to 341 to 8, and I'm from Industrial Engineering for 7th International class. So today I will be presenting the stagecoach problem, a classic example of and operations research that illustrates the principles of dynamic programming. And this problems revolves around a fortune seeker traveling from like Missouri to California during the gold rush, aiming to find like the safest and most cost effective route. So let's dive into the details. Okay, so the stagecoach problem is a well constructed example to introduce the dynamic programming. It involves a traveler in Missouri who wants to reach California during the mid 19th century gold rush. And the journey is dangerous with risks of like marauder attacks. So the traveler must like choose the safest route, and the possible routes are represented by states, and the goal is to minimize the total cost of life insurance policies, which reflect the safety of each stagecoach run. Okay, so the traveler starts in state A, Missouri, and must reach the, the state J, which is the California. And the journey is like divided into four stages, with each stage representing a stagecoach run. And the traveler has like a multiple choices at each stage, and the cost of each run is based on the safety of that route, and the total cost of the journey is like the sum of the cost of each stagecoach run. Okay, so here we see the road system and the associated costs for each stagecoach run. Like the costs are represented by CIJ, where I is the current state and J is like the next state. For example, like the cost from state A to B is 2, while the cost from state A to state D is 3. This is cost will help us determine the safest and cheapest route. Okay, so a short-sighted approach would be like to choose the cheapest run at each stage without considering the overall cost. For example, like the route, if we choosing like the route of A, B, F, I to J, it would cost 13. However, this approach may not yield the optimal solution. Sometimes sacrificing a little at one stage can lead to greater savings later. And for instance, like A to D to F is cheaper overall than A, B, F. So to solve this problem efficiently, we use like a dynamic programming instead of evaluating all 18 possible routes. Dynamic programming breaks like the problem into smaller sub problems. And we start by solving the problem for the last stage and work backward and gradually building up the solution for the entire journey. So here's the fact formulation. Yeah, in dynamic programming, we define decision variable x end as the immediate destination at each stage and the total cost of the best policies is denoted by like f end as comma x end, where s is the current state and x end is the next state. So here, our goal is to find like this f1 a and the minimum total cost starting from state A. So here we start by solving the problem for state the last stage, which is the stage 4. And at this stage, the traveler like has only one more run to reach the destination, stage A, and the cost for stage H to or I to J is like straightforward and shown in the table here. For example, like the cost from state H to J is 3, and from state I to J it's 4. So now we move to stage 3, where the traveler has two more runs to complete. For example, like two more run. If the traveler like is in the state F, they can go to state H or I, and the total cost is the sum of the immediate cost and the cost from the next state to J. The optimal choice to is the one with the minimum total cost. And in this case, going to from F to I is cheaper than with cheaper with a total cost of 7. Okay, so the similar calculations are done for states E and G. For example, from state E here, the traveler can go to state H or I, and the optimal choice is to go to state H with a total cost of 4. And these calculations help us build like the solution step by step. Okay, next we solve the problem for stage 2, where the traveler has 3 runs left. For example, if the traveler is in stage C, they can go to state E, F, or G. And the total cost is the sum of the immediate cost and the cost from the next stage to J. So here we got like the most like the optimal choice is to go to the state A, which is with the total cost of 7. Okay, so here similar calculations are done for state B and D. For example, like from state B, the traveler can go to state E or F. And both options have the same total cost of 11. So either choice is optimal. And this flexibility allows like the traveler to choose between multiple optimal routes. And finally, here we solve the problem for stage 1, where the traveler has all 4 runs left, starting from like state A to state B, C, or D. And the optimal choice is to go to the state C or D, because they has the same state. Here, 11 would be the total cost of 11. And this is like the minimum total cost for the entire journey. So based on the calculations, we can like identify like the optimal routes. If the traveler starts by going to the states C, the optimal route is A, C, E, H, and then J. If the traveler starts by going to state D, the optimal routes are A, D, F, I, and J. And all the routes have a total cost of 11. You see here how it represents from the stage 1 to stage 4, the solutions with a total cost of 11. So maybe I can conclude for all of this, I can deliver the conclusion for all of the materials that I've been explained. So in conclusion, that the dynamic programming provides an efficient way to solve like the stagecoach problem by breaking it into smaller sub problems and solving them step by step. And the optimal routes all yield a total cost of here 11, ensuring the traveler reaches California safely and at the lowest possible cost. Okay, so I just hope that all the presentation that I have has given could be clear, understanding um of the stagecoach problem and how the dynamic programming can be used to solve it. And that's all for me. Thank you for your attention.